So in this problem, we're told that Sherlock earns the same amount of interest as Irene from during the last 6 months of the 8th year. So let's figure out what exactly does that mean. So what exactly is the last 6 months of the 8th year? So if we draw a timeline, this is T. So this is the end of year 7, the end of year 8. So the last 6 months of the 8th year is actually this time span. So from T equal to 7.5 to T equals to 8. And we know that the amount of interest that Sherlock and Irene earns is going to be the same. So if I express the amount of interest earned at this time span in terms of the accumulation function, it's actually equal to A8 minus A7.5, right? Whatever the difference is the growth, and the growth is the interest, right? So let's try to find the amount of interest that Sherlock earns. So Sherlock has $100 and then he's earning semi-annual interest at a rate of I. So A8 for Sherlock is equal to 100 times I over 2 because it's compounded semi-annually, so 2 times 8. And then we do the same thing for 7.5, we just apply the formula for semi-annual interest. So this is the amount of interest that Sherlock earns. Now take a look at Irene. Irene deposits $200 and then she's earning simple interest at a rate I. So at time 8, it's simple interest, Irene has 1 plus, so for simple interest the formula is 1 plus IT, right? So her interest we're not given, we're only given it's equal to I, and for time, for this case, it's equal to 8, so 8I. And then minus 1 plus 7.5I. So this is the amount of interest that Irene earns. So just remember, this is the amount of interest earned at this time span. So now we have a formula, so we can solve this to find I. So let's try to simplify the left-hand side. So 100, 1 plus I to the power of 2, plus I over 2. And this is actually 16, and this is actually 15, right? So I'm just going to pull out 15 of these 1 plus I over 2. This expression here, this becomes 1 plus I over 2, because originally there were 16. And this just becomes minus 1, right? So I'm just factorizing, I'm just pulling the common factor out. And then for this side, the 200, I can merge these brackets together, the ones that cancel out. So there's going to be a 0.5i. So it's going to be 200 times 0.5i. And of course that's going to be 100i. And then for the left hand side, you get I over 2. So the 100 cancels out, the I they cancel out. So in the end I get 1 plus I over 2 raised to the power of 15 is equal to 2. So you see that at this point all we have to do is just to use our calculator to find I. So if you take 2 to the power of 1 over 15 and then minus 1 times 2, so that's what I is going to be equal to. You're going to find that that's going to be equal to 0.094588245. So this is the answer.